Alright, hello class. So it turned out that the recording from earlier today didn't take, and this is my second attempt at showing you how to do simple linear and multiple linear regression in SPSS. So the first thing you want to do is import your dataset. As you can see, I have the HGB dataset from Blackboard in class loaded here. And as I said earlier, we want to go through and delete these extra variables here. So I'm just holding control on my keyboard, selecting them. I'm going to right click and hit cut. That just gets rid of them, and just want to make sure that I don't have any extra variables here. I'm looking under variable view and data view just to make sure things look good. Everything seems to be fine after deleting those few extra variables. So next what I want to do is go to Analyze, go to Regression, and go to Linear. For simple and multiple linear regression, you'll go to the same thing. So Analyze, Regression, Linear. And then within here I have, I'm going to put my dependent variable, which is change, which represents the change in hemoglobin from weeks 9 to weeks 36. For these subjects, and then weight gain, water, and PS smoke for the independent variables. Now I'm going to take out these two because at first here I just want to do simple linear regression. Okay, under statistics I'm going to select some options. I'm going to make sure I have estimates, confidence intervals, model fit, descriptives, and collinearity diagnostics. Under plots, you want to select histogram and normal probability plot. Under options, you shouldn't need anything here. Make sure that include constant and equation is checked. And the rest of these should be fine. So once I'm done selecting those options, I'm going to hit OK. And you'll see the following pop up. So it should start off, it should say regression. Gives you some basic descriptive statistics. I asked for that, the mean of the change, the mean of weight gain, standard deviation, correlations between those things. You can see here I can get the R squared. The ANOVA, now this is again the test of the overall model. In the instance of simple linear regression, the ANOVA result and the regression table results for the coefficients should be the same. So meaning that if this is significant in the ANOVA regression table, the coefficient for weight gain should also be significant. So we see that the mean squared for the regression, the mean squared regression divided by the mean squared residual or the mean squared error will give us the F statistic, and that F is very large, much bigger than 4 as we talked about in class, and we do get a significant p-value attached to the F. For the coefficients, what we can do is just look here. So the first thing constant is the intercept. That stands for the intercept. So this is the beta hat 0, and this is beta hat 1. And we would interpret this as a 1 unit increase in weight gain corresponds to a negative 0.032 increase, or aka a decrease of 0.032 in the hemoglobin change. Okay, you can see that this effect here, which SPSS calls the unstandardized beta, stands for or is significant. Okay, we want to interpret the unstandardized beta. Alright, I can also run down through here. So I asked for the confidence interval, it gave me the confidence interval. The VIF is 1, that's because we only have one variable in this model. If we had multiple variables, that's when we'll start seeing VIF differ from 1. You can see here that our histogram of the regression standardized residuals doesn't appear to be normal. It's probably because our model is not classified or not specified correctly, so we'll need to specify it correctly. And then the QQ plot also doesn't appear to form to a straight line. Okay, so let's now go here and do a multiple linear regression. So we're going to do it for two variables. I'm going to go to the same place. I'm going to analyze, regression, linear. Now what I'm going to do is put water into the model. And this is like we did in class. So now I have two variables. I should have three parameters, beta 0, beta 1, and beta 2, that I'm going to estimate with beta 0 hat, beta 1 hat, and beta 2 hat. Okay, my dependent variable is still change. It's continuous. Both of my independent variables are continuous. All right. So you can see R squared. The first thing, I get some descriptives. I get correlations. The R squared is quite a bit higher by including water here. And you can see, as before with just weight gain, the model is still significant. That again isn't too meaningful, because what we're really interested in is the individual effects. Looking at the individual effects from the coefficient table, we can see that the unstandardized coefficients, these are really the beta hats right here in this column under B, that the intercept is, or beta hat 0 is 2.385, beta hat 1 or beta hat weight gain is negative 0.006, and beta hat 2 or beta hat water is 0.004. Both beta hat 1 and beta hat 2 are significant, as indicated here under the SIG dot column. So we're looking to make sure that these are less than 0.05. Okay, so this indicates to us that both weight gain and water are both significant, meaning that their regression coefficients are different from 0, or their slopes are different than 0. We can observe their estimated confidence intervals for beta, and the VIFs are also not greater than 10, so those are good to go. Also, you can see that our regression standardized residuals have gotten a bit better. They're definitely more normally distributed, and this QQ plot is really telling us something very similar to this plot here, the histogram. It's just the problem with histograms is sometimes they are skewed and it's hard to tell, and the QQ plot picks up on that a little bit better. Okay, so I think that's it for now. This movie's about 7 minutes long, so hopefully that should be able to help you get through the homework for simple linear regression. And in terms of interpretation for these coefficients, again, because these are continuous, we want to talk about 1 unit increase in weight gain corresponds to a negative 0.006, or is estimated to drop the weight gain by 0.006. And a 1 unit increase in water is estimated to increase the change in hemoglobin by 0.004. All right, that's all for now.